Hi everyone, in this video I will be talking about basic component in electronics, that is resistor. So this video is useful for those who are new to the electronics or one who want to know about the resistor. So what is this resistor? This resistor is the most important electronic device. So this is a passive two terminal electrical component. Why this is a passive? Because it does not require any external power supply for their operation. Means it cannot generate energy, but it can store or dissipate the energy. That's why this resistor is the passive material. Then the main function of resistor is to oppose the flow of electrical current. That's why this is used to reduce the flow current, adjust the signal level, to divide voltages, bias active elements, and terminate the transmission lines, and among other uses too. So how it works? So it works by converting electrical energy into heat, which is dissipate into the air. So theory, how it operates. So theory of operation, so its behavior is depends on the relationship specified by Ohm's law. So what is this Ohm's law? So Ohm's law states that voltage across any resistor is proportional to this current, and this proportionality constant is nothing but the resistance value. So symbol, as we can see in a figure, so both symbol are used for resistor. So left side symbol is used in North American resistor symbol, and right side symbol is European resistor symbol. Now this connection, so resistors are connected in series as well as parallel circuitry. When we connected in series circuitry in first diagram, then equivalent resistance is nothing but the summation of all resistances connected in that circuit. Means this R equivalent is nothing but R1, R2 up to Rn. And when this is connected in parallel circuitry, then output or equivalent resistance is nothing but the reciprocal of resistances present in that circuit. Means 1 by R1, 1 by R2 and 1 by Rn, like this. So types. So these types vary depending upon their construction, power dissipation capacity, tolerances, like this. But there are main three types of resistors: fixed resistor, variable resistor, and special resistor. In fixed resistor also divided into three types: carbon composition resistor, wire wound resistor, metal film resistor. Then variable resistors, this is rheostat and potentiometer, this is the best example of variable resistor. And in third, special resistor, light dependent resistor, that is LDR, voltage dependent resistors, and thermistor. So I will explain all types briefly. So first is carbon composition resistor. So this is also called as a carbon resistor. So this is provided with different color band on their cylindrical body. So as we can see in this figure, there are different bands on this cylindrical body. So this band shows, or these bands are useful to find the resistance value of that resistor. So this is made up of a carbon clay composition covered with plastic case, and these leads are made up of tin copper. So there are advantages. So this is readily easily available. So it is low cost, very durable, and it is available in wide range, that is 1 ohm to 22 mega ohm. Then disadvantage is the carbon composition resistor is very temperature sensitive. Then next one is the thermistor. Thermistor is nothing but the thermal resistor. Means its resistance value changes with temperature. So this is made up of semiconductor materials. So it has also two types, that is a NTC and PTC, that is negative temperature coefficient and positive temperature coefficient. So in this negative temperature coefficient, resistance value is inversely proportional to temperature. Means as temperature increases, resistance also decreases, or temperature decreases, resistance increases. But in positive temperature coefficient, resistance value is directly proportional to temperature. Means as we can change as we increase the temperature, resistance also increases like this. So advantages, so this is used to detect very small temperature change. Means if there is very small change in temperature, then resistance value changes in large value, so we can easily find out very small change temperature. Then third one is the wire wound resistor. So in this type, from this figure we can see that wire of magnin or constant is wound around the cylinder of insulating material, and this wire, wounded wire, is covered with insulating material. So its change in resistance value with temperature is very negligible, because temperature coefficient of resistance of magnin or constant is almost zero. That's why change in temperature with resistance is very negligible. This has also advantages and disadvantages. So in advantages, this is easily available for a wide range rating, that is 1 ohm to 1 mega ohm, and it is used for a high power application. But there are many disadvantages over the advantages. Means cost of this resistor is much higher than carbon resistor, that is previous we have seen. Then inductance arises because of this coil like structure, as we seen in figure. And then at high frequency, the behavior of circuit may be changed due to this reaction. But this problem can be solved if one half of the wire is wound in one direction and another half of the wire is wound in another direction. Then inductance arises due to these both wire can cancel each other and inductance will become nil, like this. Then fourth type, that is metal film resistor. This is also called as carbon film resistor. So this is constructed by deposition of thin film of conductive material such as a pure carbon or metal on an insulating core. So and this cap is fitted on both ends of resistor, we can see in that diagram. And the size of this type of resistor is much smaller than wire wound because of this constructional features. Now this variable resistor, this is the most commonly used type, that is variable resistor. So in this type, resistance value can be adjusted. Means um, uh, we can see in a figure. So there is a shaft and wiping contact is present. So with the help of this shaft and wiping contact, we can adjust the resistance value. So rheostat and potentiometer, these are the best example of variable resistor. So this resistor can be can also be linear sliding type. So how? Because the sliding contact, when sliding contact moves on resistive element linearly for adjustment of effective resistance, then resistance can be adjusted. So there are application of a variable resistor. Means this is most significant component found in many electrical devices for controlling um, tone, bass, as well as volume. Also used in computer monitors for color or positioning, as well as dimming or switching lamps. So now sixth one is the non-linear resistor. So this is also called as a varistor. So this is a very popular for non-linear VI characteristics of curve, and it does not obey the Ohm's law. So depending upon their construction, this has also three types, that is silicon carbide disc type varistor, silicon carbide rod type varistor, and zinc oxide varistor. So now last one is the light dependent resistor, that is the LDR. So in this type, this resistance value can be changed depending upon the falling light. Means resistance depending on the intensity of light falling on it. So as we see in a figure, this light sensitive material, that is a snake like structure, which is placed on a insulating substrate. So this light sensitive material made up of cadmium sulfide, and insulating substrate is made up of ceramic material. But when this light dependent resistor means LDR placed in dark place, then resistance value shows very high. But when light falls on this LDR, then resistance value going to decrease. Means when light falls on that, then conductivity increases and resistance value decreases, like this. There are many application, means this LDR used in light sensors, in cameras to detect presence of light, also light intensity measure multimeters. Also in manufacturing industry, this LDR used as a sensor for counting the packets moving on conveyor belt. Then light activated control circuits in photosensitive relays, alarm circuit, simple fire alarm circuit, also in street lights. So when we use in street lights, then automatically turn on in the night time. Also in modern television, computer screens for automatic brightness, like this. So this has also advantages. Is low cost device, smaller in size, it is a very simple device, and it is connection is also very simple. Then disadvantages is not much sensitive device, and it is not accurate, means this shows inaccurate result if working temperature changes. Now this color coding of resistor, means if there is some band present on this resistor, so from that band we can find out the resistance's value. So value of resistor is usually defined using color codes. So depending upon number of color band, so these resistor are known as 4 band resistor, 5 band resistor and 6 band. Means usually commercially available resistors can have 4 band, 5 band and 6 band. So depending upon that bands, we can say 4 band resistor, 5 band resistor and 6 band resistor. So we can see in that figure. In first figure 4 band resistor is present, second figure 5 band resistor, and third figure is 6 band resistor. So in 4 band resistor, so how to calculate the resistance value in 4 band? So out of this 4 band, first two band defines first digit and second digit, third band defines the multiplier, and fourth band defines the tolerance. So right side there is a 4 band resistor color code chart is shown. So this table shows the relationship between the which color present in that on this resistor, and there is a value for that color. So first band and second band, means second and third column shows the value for that color, and third and fourth column is shows the multiplier and tolerance. Means I will give you example, so from that you can get more idea how to calculate the resistance value of resistor. So this is an example of 4 band resistor. So this resistor has 4 band. This first band is brown, second is black, third is brown, and fourth one is the gold. So first as we have seen on table, like this, those first and second band shows the first digit and second digit. So brown color shows the value 1, and then black color shows the value 0, and then third is the multiplier. So multiplier is nothing but the this brown is multiplied by 10, and fourth band is the tolerance, that is the 5% gold. So total, when we combine this total, then this resistance value is nothing but the 100 ohm plus or minus 5% is tolerance. So like this 5 band resistor, when there is 5 band on resistor, then first band defines first digit, second band defines second digit, third band defines third digit, and fourth band defines multiplier, and fifth band defines tolerance. So this is a table for color code of 5 band resistor. So depending upon which color, so that depending upon which color, this resistance value can be changed. So for example, this is a 5 band resistor. So first band is the blue color. So with the uh, respective of this table, this blue color shows the 6 value. Then second band is green color, so second green is shows the 5. Then third band is the red color, then value is 2. Fourth band shows this multiplier, so this multiplier is nothing but multiply by 1 because of this one black color. And fifth band is the gold, that is 5% tolerance. So when we combine all, then this total resistance of that resistor is 652 ohm plus or minus 5% tolerance. Now in 6 band resistor, 6 band are present on this resistor. So first 3 band shows the first digit, second digit, third digit. Then fourth shows the multiplier, fifth shows the tolerance, and last one shows the temperature coefficient of resistor. So this is a table for 6 band color code resistor. So this column shows the what is this range, what is the value for with respect to of color. So for example, this is a 6 band resistor. For example, first band is the blue color, so value is 6. Then second band is the red, so value is 2. Third band is violet, then value is 7. Fourth band shows this defines multiplier, so 10 raised to 0 is nothing but the 1. Fifth band is the multiplier, tolerance, so 5% tolerance. And sixth band is the nothing but gold, that is the temperature coefficient. Sorry, I did one mistake, that is the temperature coefficient, that is 25 ppm per Kelvin. So total is 627 ohm plus or minus 5 percentile is the tolerance, and 25 ppm per Kelvin, like this. So now thank you for joining me. So don't forget to like, comment and subscribe to my channel.